All right, guys, here we go. So we're going to deal with rational exponents. It's our first week back, so we're kind of getting everything going here. Also, don't forget, get caught up over break coming up. Make sure you're caught up on all the assignments. We'll accept late work for a while, so make sure you're kind of dialing it in now that you're back in school. Take advantage of the time that we're giving you. We're going to do a little bit of introduction here, and then when we get back, we're going to do even more of it. So we're going to talk about what are called rational exponents. You know what rational exponents are, you just don't, you haven't seen them the way you need to see them. So I'm going to write something you've seen before here. And I'm going to put an x in there. So everybody knows what the square root of x is. So this is in our root form, and we need to, or called the nth root form. You'll see it called the nth root, right? Okay, so the idea is this, that the nth root, the reason they call it the nth root is because if we look at this, there's always this little number right here, right? And that can be 2, that can be 3, that can be anything. We also know that this whole thing is raised to the first power. So you guys kind of see what I'm talking about? So the radical here is any number, that's why they call it n, so the nth, we don't know what it is. And this whole thing is to the first power. So what they mean by a rational exponent is it's basically a fractional exponent, and this is how it works. X, and then, you know what, I'm going to make this in blue. We get a fraction. The power goes on the top, or the numerator, and the root goes here. Or sorry, I had to put a 2 there. Here. So the nth root of x is 1 x to the 1 nth power. So let's take something you know, which is just the square root of x. We know that this thing is a 2, we don't ever write it, and that's a 1. So that means that this is x to the 1/2. Okay? So when it can change, it can be whatever you want it to be. So it could be like, let's say this is z, the cube root of z to the 2nd power. Go ahead and try that in your head real quick. Z to the what? Z to the 2/3 power. That's really all we're talking about when we're talking about rational exponents. We're able to take the roots and turn them into rational exponents. So let's just kind of take it one step farther real quick and do something like this. Let's take 16 to the, let's look at this here. 16 to the cube, the square root of 16 cubed, which is going to be, the square root of 16 is 4 cubed, so that means it's 4 cubed, which is 64. Put that in your calculator. So let's write it as, let's write an 8 to the 2/3. We know from previously that this is our n and this is our power. So 8 goes in the radical, 3 goes out here, squared goes there. So we get the cube root of 8 squared. Well, what's the cube root of 8? 2, because 2 times 2 times 2. Square it. Okay? So my answer is 4. So that's what they mean by rational exponents. You can take a fractional exponent, turn it into a radical. You can take a radical and turn it into an exponent, and you can find your answers that way. So, let's tackle some equations. So, let's just do one you guys know. So, x plus 1, square root of x plus 1 equals 2. Just throw that one out there. Okay, so you guys know that we square both sides. So we get x plus 1 equals 4. Okay, and then with x equals 4 minus 1, x equals 3. So yeah, I get 3, right? So I got a question for you. Why does the radical disappear? Everybody ever wondered that? You may not have. You may be like, I didn't wonder. I wasn't even paying attention the first time, Mr. Lasky. Hold on, let me double check and make sure my video is still recording. All right, we're almost done. But think about it. We square it and that just goes away. Well, why? So there's a little step that we don't show, which would be super helpful when we get to this step. So let's just, this is the why. Why does the radical disappear? And I'm probably spelling it wrong, so I'm not going to worry. But disappeario. Disappearance. Whatever. All right, so why does it disappear? Why does the radical disappear? Well, what's another way to write this? Well, there's another way is to write it as a fractional exponent. So if I take this piece here and I write it as a fractional exponent, I get x plus 1. Remember, this is 2, the power is 1. X plus 1 to the 1/2, which is 2. So I know I have to get rid of this fraction because I can't do anything with this x plus 1 until I get rid of that fraction. Well, how do I get rid of the fraction? I multiply by its reciprocal. What's the reciprocal? 2 over 1. But what I do to one side, I have to do to the other, so I got to multiply this by 2 over 1. So 1 times 2 is 2, 2 times 1 is 2. We cancel those out, and they disappear. 1/2 times 2 is 1, so I get x plus 1, because those are gone, to 2 squared. And then x plus 1 equals 4, x equals 3. Same exact answer. This is the mathematical reasoning behind it. It's the inverse of it, but it's the inverse of it because we have to write it as a rational exponent and we multiply by its reciprocal. This is the key piece. Multiply by its reciprocal. Multiply by rational exponent reciprocal. That's the key, okay? And you're like, well, who cares? Can't I just square both sides? Yeah, you can square both sides right here because it's the easy one. This is the concept we need to cover, multiplying rational exponents, okay? So, as we tackle this, let's take it and move it to a different setup here. All right. So, let's just move it to, let's say, the cube root of x plus 1 equals 2. Well, x plus 1 to the 1/3 equals 2. I have a fractional or a rational exponent. I have to multiply by its reciprocal. Those cancel. X plus 1 equals 2 to the 3rd power. X plus 1 equals 8. X equals 7. Key piece right here. Okay? Key piece right there. So, Remember, we're multiplying by the reciprocal of the rational exponent. So let's go one more so you guys can kind of see how it works. Let's do hopefully that works. If not, it won't work. All right, let me do it in my head real quick. It should, I think. Yeah, it should. So here we go. All right, so I got to get this all by itself. So I'm going to move the 1 over. So I'm going to get 4 because I subtracted 1 from both sides. So that leaves me with the cube root of x squared. I'm going to make this into a rational exponent, which is going to give me x to the 2/3 power. Power goes in the numerator, nth root goes in the denominator, equals 4. Okay? Now how do I get rid of this? It's that step that we never told you before. I have to multiply by its reciprocal. And I have to multiply by its reciprocal. Okay? So now if I look at this, these cancel, right? And I get x over here. Look at that, I'm close to an answer. And I've got 4 to the 3/2 power. Remember, this is the n root, and this is the power. So that means that I have the square root of 4 to the 3rd power. Square root of 4 is 2 to the 3rd power. Therefore, my answer is 8. Key step right here, guys. Changing it into a fractional exponent, multiplying by its reciprocal. That's what we're introducing with rational exponents, guys. Good luck. You can look at examples 1 and 2 on 5-6 and examples 2 and 3 on 5-7 and see what we come up with if you need more help.